So let's look at this example, which asks us to calculate internal rate of return. This one says a firm is contemplating purchasing a new production machine that will cost $200,000 initially, have annual operating and maintenance costs of $35,000, and yield annual savings in material and labor of $70,500. Have a useful life of 10 years and have a salvage value of $10,000 at that time. Note that minimum attractive rate of return is 10%. What is the IRR? So let's start by drawing the cash flow. It looks like there is an initial investment, so that's a negative. Annual O&M cost is $35,000 each year. There's an annual savings of material and labor, and have a useful life of 10 years, salvage value of $10,000 as well. So let's put all of them on a cash flow. So here's the cash flow that we have in this problem. We have a negative $20,000 initial investment, some uniform annual cost, and some uniform annual benefits, plus a salvage value of $10,000. So the first step is to set the net present worth equal to 0. So net present worth is equal to negative $200,000 plus the difference between benefits and costs at each year is $70,500 minus $35,000. And that is a uniform series over 10 years. So to calculate the present worth of that, we multiply that to P given A at I star, and that's the IRR that we're looking for, over 10 years, plus the last piece is the salvage value, and that is $10,000 positive times P given F I star 10 years. Now, to find the I here, we have two unknowns here. So one effective way of approaching this is to just try two different I values, two percentage values, in order to get a negative net present worth and a positive net present worth, and then use those two values and use linear interpolation to find the approximation of the IRR. Let me make that clear. So let's say that we try, solving this statement here at 12%, okay? And that will result in, if you do the calculation, you will get $3,801.83. And that is because this factor is 5.6502, and this factor is 0.3220, and that's at 12%. Now let's do the same and calculate net present worth, this time at 18%. Okay, at 18%, these two factors are 4.494 and here 0.1911. And this time, if you do the calculations, you will get negative 38,548 and 81 cents. Okay, so now we have a negative value and a positive value for net present worth. We know at this point that IRR is somewhere between 12% and 18%, because net present worth at IRR, or that I star, should be equal to 0. So what we do here is we do linear interpolation to estimate IRR, which is between these two values. How do we do that linear interpolation? Well, we know that at 12%, the net present worth was $3,801.83, and at IRR supposed to be equal to 0, and at 18%, it's negative $38,548 $2.81. Now, what we can do is we can solve for IRR. So IRR minus 0.12 over 0.18 minus 0.12 is equal to 0 minus 3,800.183. And that's how you set this up to approximate IRR. Now you can solve this for IRR and you will get IRR of 12.539%. And that's an approximation, it's a linear approximation. And what's important here to us is that IRR is greater than MARR, right? And when IRR is greater than MARR, the conclusion is to make the investment. Why? Because you will make more return on your investment than do nothing, because do nothing will give you 10%, assuming that you're leaving your money in some type of account or some type of investment option that gives you 10% interest. Taking this project will give you more return. In the next video, we're going to take a look at the same example but in Excel, and we want to look at the relationship between present worth and IRR.